Sorry about that, I just realised my microphone was turned off. So what I was just doing is introducing where you can find my live streams on mathslessons.net. That will give you all the information about my live streams and whether they're happening or not happening. And you don't need to register, you just click on the links to get into the live streams. Anyway, first question, what is the equation of this line? You probably had a little bit of a go at it. I'll give you 60 seconds to get started. Okay, so here we go. Equation of a straight line. If you've got something like this where you can see obviously where it crosses and intersects the y-axis, we can use y equals mx plus c as our way of doing this. And m is where is the gradient. And c is where it crosses the y-axis, or the y-intercept. So it's where it crosses the y-axis. So where it crosses the y-axis is -2. So we now know that c is -2. The gradient, if we look at how far we go along and how far we go up, if we look at this little triangle here, we can see we go 1 unit along and 3 up. The gradient is how much you go up for every 1 you go along. Or you could think about it as the change in y over the change in x. So the change in y is 3 and the change in x is 1. So therefore the gradient will equal 3 over 1, which equals 3. So the equation of our line is y equals 3x minus 2. Okay, just taking up a little level. Here, find equation of gradient 7 through the point -4, 8. And I'm just going to give you another 60 seconds to do that one. Okay, so now you could use y equals mx plus c to do this, but a much better way is to use this equation. If you've got a point, if you've got m equals the gradient, and you know the gradient, and you know that it goes through the point AB, so it goes through this. So it goes through this point. Then we know that y minus b equals mx minus a. So basically you take the y value it goes through away from y, take the x value it goes through away from x, and then times by the gradient. So if you struggle to remember which way a and b go, remember y goes with the y and the x goes with the x, and that will help you remember this okay. So we know the gradient is 7, and we know the y value it goes through is 8, so b is 8. And we know the gradient is 7, so put the 7 in, and we put the x in, and we know the point this goes through, so it's -4. So you take that value away, and because it goes through the -4, we end up with -4. And we could simplify this to get it in mx plus c form, but if they don't tell you how to write it, this is a perfectly okay answer at GCSE. multiply out the brackets, 7x, that's plus 4 times 7 is plus 28. Then I add 8 to both sides, and I get y equals 7x plus 36. So do learn this formula. It speeds up a lot of things. It gets you straight to the answer without any working, and is much more powerful than y equals mx plus c when you're given a point on the line, or even 2 points on the line. And I suggest you try using that for all the questions we've got left on this live stream and practice using it. So here we go. Here's one where you've got to find the gradient first. So let's see if you can polish this off in 60 seconds as well. Okay, so here we go. We are going to find the equation line through the points minus 8, 4 and minus 3, 11. So we need to find the gradient. So first, and the gradient is the change in y. So we could do 4 minus 11. So we take that point away from that point. And when you do the x, make sure you do that point away from that point. So we've got minus 8 minus 3. Okay, so make sure these 2 points come from there and these 2 points come from here, or that you're consistent which way round you do it. So you got 4 minus 11 is 15. 8 minus 3, so that's plus 3, so that's going to be minus 5. So 15 divided by minus 5 is minus 3. Now remember, using y minus b equals mx minus a when it goes through the point AB. So we know, let's choose, it doesn't really matter which one to choose, just use minus 8 and 4. So y minus 4, because b is going to be minus 4, equals m, which is minus 3, x, and we've got a is minus 8, so we've got minus 8, because 8 is negative, and that actually is an equation of a line. That could be a perfectly good answer. Let's just simplify it and make it neater. So we multiply out the brackets, minus 3x, that's going to give me plus 8 times minus 3 is minus 24, and I'm going to add 4 to both sides to get minus 3x minus 20. Now sometimes they ask you to write it in the form y equals ay plus bx plus c equals 0. In that case we would write y plus 3x plus 20 equals 0. So everything is on the left hand side. Right, next one. I'm just going to do about 6 of these just to get you going and make sure you really got this sorted. This one should be really easy now, so let's just do 30 seconds on this. Okay, so there we go. We're going to use y equals mx plus c because it works, makes sense for this one. We know it goes through the y-axis at 4. Now the gradient, now we can see it goes down by 1 and along by 2. So it's minus 1 down and 2 along to go from that point to that point. So the change in y is equal to minus 1, and the change in x is equal to 2. So the gradient is equal to minus 1 over 2. So therefore y will equal minus a half x plus 4. Okay, so using what I taught you before, try and do this one. 60 seconds should be enough for this. Bad at going blank there. Hopefully you got enough of that you were able to do the question. So find the equation line with the gradient minus 2/3 through this point. So again, if we use y minus b equals mx minus a, so we've got the point minus 6, because y is the b value, the y value that goes through is minus 6. Gradient is minus 2/3. X minus a, which is 4, and it wants it in this form. Now I reckon when you do this, let's just make this all nice. There you go, just put the 2/3. I'm not going to multiply out the brackets yet, because I reckon times by 3 next. So times by 3, you end up with 3y plus 18, and then you're just left with a minus 2 on this side. So minus 2 times x, and minus 2 times minus 4 gives you plus 4. And that speeds up and keeps everything nice and neat. And now if we get everything onto the left side like it wants, you've got 3y plus 2x. Bring the 2x, add 2x this side, get it on this side. Take off 4 gives us minus 14 equals 0. Now I've got a couple more to do, but I think that's enough practice. Just one more left on the video, but we'll move on because I want to get on to these parallel and perpendicular lines, which are a little bit trickier questions. So let's give you 60 seconds to see if you can work out if these lines are parallel, perpendicular, or neither. Okay, so let's have a look at this. Now, I reckon to get both of them looking the same, because what we need to work out is, are the gradients the same, parallel? Do the gradients times together to give you minus 1? So if you have one gradient, let's call the first gradient m1, times the second gradient m2, if they equal minus 1, then they are perpendicular. So if they're the same, they're parallel. If they times together to give you minus 1, they're perpendicular. And if it's neither of those, then they are neither. So let's rearrange this one. So we're going to get 9y equals 81 minus x. Divide by 9. 81 divided by 9 is 9. Minus x divided by 9 gives us minus 1/9 of x. And you might think it's minus x over 9. Remember, that's one lot of x over 9, so you can think about it as 1/9 of x. So our gradient here is minus 1/9. Our gradient here is 9. So if we do minus 1/9 times by 9, we get minus 1. So therefore, they are perpendicular. Okay, because their gradients times together to give us minus 1. Right, do the same on this one. If you think you got the answer, just chuck it into chat so I know if you finished it or not. Right, so now this, I gave you a bit more time. Might have guessed there's a bit more work to do on this one because we want to probably rearrange both. Okay, so you get y equals mx plus c, so we can find the gradient for both. So if we rearrange this one, we're going to get 6y, let's take away 12 and take away 4x. So minus 4x minus 12. Divide by 6, we get y. Divide this by 6, we get minus 4/6x. Divide this by 6, we get minus 2. Now let's rearrange this one. So we get 4y equals, take away the 6x and take away the 12. And we get, divide by 4, we get minus 6 over 4. And we get minus 3. Now if the gradients are equal, which they're not, because that's 6 over 4 and that's 4 over 6, then they would be parallel, but they're not. Well, what about perpendicular? So let's do minus 6 over 4 times minus 4 over 6. And you can see we get minus times a minus a plus, 24 over 24, which equals 1. So therefore, they are neither parallel or perpendicular, because this is not minus 1, is what we need it to be for them to be perpendicular lines. Okay, right, I'm just going to do one more from this section of the workbook. There are a few more questions, but I want to get on to a couple of exam questions before we run out of our half hour. So I'm going to give you, find the equation line parallel to this through this point. Should only take you 60 seconds if you use the formula we came up with earlier in the lesson. Okay, so find the equation line parallel to this through this point. So the gradient of our line that's parallel will have the same gradient, and the gradient of this is -9. Okay, so you've got gradient of -9, and it's through this point. Remember what we said, y minus b, if it goes through the point AB, equals mx minus a. So we're going to put that in, y minus b, which is -17, so minus 17, equals -9 times x minus 3, minus the a value. So we get y plus 17 equals -9 times x, -9 times -3 is plus 27. Take them away, we get y equals -9x plus 10. If you want to make everything positive, you could write it out like this as well. Admittedly, if this is a GCSE question, you will get full marks at this stage because they usually say or equivalent. And this is an equation of a line. Not simplified, but it does work. Now, there are a couple of more questions there. Finding line perpendicular. If you're finding perpendicular, then the gradient here is -10. If it's perpendicular, it'll be -1 over -10 to get the perpendicular gradient, which will give you 1/10. Because remember, they must times together give you -1. So therefore, divide -1 by -10, you get 1/10 for your perpendicular gradient. Now I'm going to rub that out and leave you to have a go at that later. You can go to the OneNote notebook and you can download any pages and copy them across to your own notebooks. And then there's another question and another question. But I want to get on to a couple of exam problems on graphs, and here's our first one. Okay, so I'm going to give you 3 minutes to have a go at this one. Okay, so what we have here is a speed time graph. And what you need to realize is that the gradient in a speed time graph is the acceleration, and the distance under the graph, the area under the graph is the distance you've traveled. So the acceleration is going to be the gradient, and the gradient is going to be 175 divided by 1. And 175, because that's how fast they got to their speed. So the change in y is 175, and in 1 second, so 175 divided by 1. So it's 175 meters per minute squared. This axis is meters, this per minute, and this one's time is minutes. Find the distance d covers in the first minute. So it's 175 high, 1 across, so it's a triangle, times that by a half, and you will get your answer to that, which is going to be... have I made the mistake here? No, I've made a mistake there. Sorry, that's not 170. I knew there's something wrong with that. So that's 170, halfway between 180 and 160. So 170 divided by 1. Okay, so now the distance that's travelled in the first minute is going to be 170 times 1 times by a half. So that will give us 85. And then we're going to work out in the first 10 minutes. So the area under the whole of the graph is what we're going to work out next. And the best way, I think, to work out this bit here, actually, I'm just going to make a rectangle here. And that's going to be 5 times 1, what's that, 175. So that's going to be 5 times 175 to get that area. And then I'm going to take off this bit here, which is 80, so it's 20, so it's going to be 95 times 1. So I'm going to minus 95 from that. So I've got 5 times 175, which is 1850, minus not minus 95, because actually that's going to be 95 high times 1, then divide by 2, so it's 90 high. I keep doing that, I keep calling that 5, and I mean 0. So that's going to be, let's just talk about that again. That's 90 high, okay, 20 onto 70 is 90. Times by 1 is 90, divided by 2 is 45. So I'm going to take off 45. And that leaves me with 805 for this section. Okay, and then this section is just going to be 4 times by 80. So that's just going to give me 320 for that section. So I've got 85. Plus 805 plus 320. That together gives me 1. Add that all up, and I get whatever. I think I've made a mistake somewhere. No, that gives me, sorry, add that together gives me 0, 1 there. I just put the 1 in the wrong place, and then put the 1 there, take 1 across, and that gives me 1210. Sorry about that. I just put my 1 in the wrong place by mistake. Okay, who goes to Raj was a constant speed of 6 kilometers an hour. Okay, 6 kilometers an hour. So that's going to be 6,000 meters in 1 hour. Okay. And this is over 10 minutes. So if we divide that by 60 to get how many he walks each minute, so 6,000 divided by 60, that will give us 100 meters walked every minute, and he's going to have 10 minutes, so it's 10 times 100 to get how far he's walked, which is 1,000 meters. So therefore he walks 1,000 meters, so Dieter walks the furthest, and she goes 1,210. Take away 1,000 leaves you 210 meters. Sorry about that, there's a bit of a mess. Okay, next one, much trickier question. This is verging on level 8 stuff here. So let's see if you've got your wits about you and whether you can convert everything you know about straight line graphs into this problem where you've not got one of the numbers. So you've got to put n's and p's and q's. Everything's going to be done in terms of that. Lots of unknowns. Okay, so don't be afraid of putting them in. There's 3 minutes. Off you go. do realize that n is in every single answer. Don't let it put you off. Don't let it put you off. Right, last question. Let's get through this. In the top right hand corner you will notice a little I button. It has a question there to how useful you found this stream. Also it gives you the link to the website as well. Now what we got is a parallelogram of A, B, C, D has vertices. A is 4, n. B is 6, 5, n. D is 22, n. And C is P, Q. Find the gradient of AB. So we want to do our change in Y. So the gradient will equal the change in Y. So it's going to be 5n minus n over 6 minus 4. 5n minus n is 4n. 6 minus 4 is equal to 2. And 4n divided by 2 is just equal to 2n. So there we go, gradient is equal to 2n. Find the equation of the line through CD in terms of n. Now, they deliberately made this tricky, but what you should realise, you have a parallelogram. So these are parallel. So the gradient over here is still 2n. The gradient equals 2n. And we know a point on the line is 22n. So we can use y minus b equals mx minus a. So the b value is, the y value is going to be n. M is going to be the gradient, which is 2n. X minus the x value, which is minus 22. So therefore we get y minus n equals 2nx, times that out, 2 times n times x. 210 times minus 22 is minus 44n. Scroll down a little bit. Okay. And then we get y, add on the n, we get 2n. I made a mistake. Just want to check out I made a mistake. 2nx minus 45n. I'm just checking this because I got a different answer previously, but I can't see anything wrong with this. 22n minus n. That looks okay to me. Right, so that's that bit. Find the equation of diagonal through BD. and give your answer in the form ax plus by minus c. So we want to find the diagonal through BD. So first of all we need to find the gradient. So the gradient will equal the change in y, which is going to be 5n minus n, over the change in x, which is going to be 6 minus 22. Just create a little more space. So that's going to be 4n over minus 16. So that's going to be equal to minus n over 4. 4 and 16 goes 4 times. That's our gradient. So we now know it goes through this point 22n here. So we get y minus the y value, minus n, equals the gradient minus n over 4 times x minus the x value, which is 22. Now, it want it in terms, so you've got ax plus by plus c. So let's times that by 4 to get rid of the fraction. So we get 4y minus 4n equals, now we've got minus n times x is minus nx. Minus n times minus 22 is plus 22n. So let's add on the nx. So we get 4y plus nx. And then we've got minus 4 minus another 22. That gives me minus 26n equals 0. And we've now written it in the way they want. So the value in here will be n, the value in here will be 4, and the value in here will be 26n. Okay, so that was a bit of a tricky one for a level 6 to 7 question, possibly verging on level 8. So hope you found that useful, and tomorrow we'll be doing some level 8-9 stuff, and then next Wednesday we'll come back to the level 6-7. But if you want to check out the streams, you can always go to the website. Thank you very much. Sorry, just realised I've made a mistake in there. There was a mistake. I knew there was something. There's minus n here. I had this gut feeling. Minus n here, minus 44. I've got to add on the n to get minus 43n in this question. So it should be y equals 2nx minus 43n.